Okay, now let me see if I can get this to be happy. Alright. Darn it. Get out of here. Okay, so there we go. So on number 15, we're looking at the volume in milliliters from an 18 molar H2SO4 solution to contain 2.45 grams of H2SO4. So what I said was, okay, I'm going to take my 2.45 grams of H2SO4. I'm going to go to moles. 1 mole is 98.1 grams of H2SO4. So those are going to cancel out, and I found out that I had 0.0250 moles of H2SO4. And they want the volume. So I'm going to say, well, the volume is going to be molarity equals moles over liters. I want liters out. So I'm going to say liters volume is equal to moles over molarity. So the number of liters would be 0.0250 moles over 18.0 molarity. So when I did that, I got the liters to equal, I got 1.39 milliliters. Now when I first saw it on my calculator, it was 0.00139 liters, but I converted that to milliliters. Doesn't really matter. It works either way. All right, let's look at number 16. Number 16 says what volume in milliliters of 12 molar HCl is needed to contain 3 moles of HCl. So I said, okay, well, I know that I have 12 molarity is equal to 3 moles over X. So X is going to be 0.250 liters or 250 milliliters. Same thing. Okay, number 17 says how many grams of calcium hydroxide are needed to make 100 milliliters of a 0.0250 molar solution. So I said, well, 0.250 molarity is equal to X moles over 100 milliliters is 0.100 liters. So I multiplied 0.100 times 0.25, and when I did that, I got 0.025 moles. But I can't leave it in moles because they asked me about grams. So I said, well, 1 mole of CaOH2, and then I did my gram formula mass, my GFM, is 74.1 grams of CaOH2. So I multiplied that across, and when I did, I got 1.85 grams. Okay. Okay. Now you're given a concentrated sulfuric acid, and we need to get it from 18 molarity into a molarity of 5, and we want to make a liter. So I said, well, I'm going to do a dilution. 18.0 times some new volume must equal what I want, 5.00, times 1 liter. So I solved for my new volume, and basically I took 5 times 1 divided by 18, and when I did that, and I did it correctly, I got 0.278 liters. Okay, now I need to tell how to do it. Okay, so I need that much, so what I'm going to do is I'm going to go to a fume hood, because sulfuric acid is very strong. I'm going to pour in some water. Probably 300 or 400 mils. Doesn't really matter. Then I'm going to add my acid slowly, very slowly. And then I'm going to fill the rest of the way up to the 1,000 milliliter mark with more water. Stir it up. I'm good to go. All right, calculate the percentage of water in the copper 2 sulfate pentahydrate. Wow, that sounds crazy. So let's scroll on down and see if we can work that one. All right, so copper 2 sulfate pentahydrate. Copper 2 sulfate. This is a +2 and a -2, so I don't have to do a swap and drop because they're the same. Penta means 5. Hydrate means water molecule. So I'm going to get the GFM before I do anything. So what I did there was I said, okay, I'm going to look up copper, and I think it's 63.54. You can check. And then sulfur is 32.1. And then 4 oxygens is 64.0. And 5 waters, each water is 18. 18 times 5 used to be 90. I think we're still good there. And so when I added those all up, I got 249.4. 249.4 grams. So obviously this is off a little bit, but you can look it up. Okay. And I said, okay, the percentage of water. Well, I had 90 grams of water out of a possible 249.4 grams times 100%. So when I did that, I got 36% water. Okay. All right, a solution of 1 molar NaCl is available. How many milliliters of this solution are needed to make a total of 100 milliliters of 0.75 molar NaCl solution? So it looked like to me I was going to do a dilution, so I said, okay, I have 1 molar. I need some volume of that so that I can get 100 milliliters, or 0.100 liters, of 0.75 molar. So I solved for volume 1, and when I got volume 1, I got 75 milliliters, or 0.075 liters, which is equal to 75 milliliters. So either one is correct. It doesn't really matter which one you use. Okay, if a bottle containing rubbing alcohol has a liter and the label says that it's 70% rubbing alcohol, how much alcohol is in the bottle, how much water? So I just said, well, I have 1,000 milliliters. 70% of it is rubbing alcohol, so that's 700 milliliters of rubbing alcohol. And then if I started with 1,000 milliliters, 700 of it was alcohol, then I have 300 milliliters of water. All right, going to pause for a minute. Okay, so we have a graph. I can't see it, but you can have it out beside you, and it says which of the salts shown on the graph is the least soluble in water at 10 degrees Celsius. So I find 10 degrees Celsius, and let me see if I can find that for you. So I roll on down here, and I find 10 degrees Celsius, and I'm looking for the one that is least soluble. So if this is 10 degrees here, that's the first one I run across. That one looks like KClO3, so I'm going to say KClO3. All right, KClO3, the answer to number 1. Okay, number 2 says, which of the salts shown on the graph has the greatest increase in solubility as the temperature goes from 30 to 60? So you're looking for the biggest move vertically. So here's 30, here's 60. So I said, well, it looks like to me this one has the steepest slope, term you learned in math. So I'm thinking that this is the largest vertical increase. And so I picked KNO3. Now if you want to look at the math, it went from about 48 here to about 104 right there. So that's the largest jump. Okay. All right, number 3. Set at 20 degrees Celsius, a standard solution of sodium nitrate contains 100 grams of solute and 100 milliliters of water. How many grams of sodium nitrate must be added to saturate the solution at 50? So I said, well, let's go back and find that. So I erased all this gobbledygook, and I was looking at sodium nitrate. So that's NaNO3. So here it is. And at 50, here's my 50 line. At 50, it looks like it's at about, I don't know, 113. Well, if I've saturated it with 113 grams and I already had 100 grams, then I only needed 13 more grams because there were already 100 grams present. Okay, number 4. Number 4 said, at what temperature do saturated solutions of potassium nitrate and sodium nitrate contain the same weight of solute? So I looked for potassium nitrate and sodium nitrate to cross each other. Here's potassium nitrate, here's sodium nitrate. So that's where they cross each other, so that's where their mass is the same. So I just shot down here, and it looked to me like it was about 72 degrees Celsius. Okay, number 5 said, what two salts have the same degree of solubility at approximately 19 degrees Celsius? Well, here's 20. So I'm going to look where two lines cross each other. And I found that the two lines crossed each other were NaCl and NH4Cl. Then I also said, well, I'm going to keep on going up and see if anybody else crosses at 19 degrees Celsius. And I picked KCl and KNO3. So let's see if that makes sense. KCl is this little rascal right there. And KNO3, yep, about right there. They cross each other. So KCl/KNO3.